Cummins, Powerstroke, and Duramax. What are the real differences between these engines, and should it impact your ownership decision? In today's video, I want to talk about the actual differences between these engines, not just regurgitate specs for you, and explain what those differences really mean. Today's video is sponsored by the new Power Service Injector Flush. More on them later. You're watching Morton's on the Move, and today you're going to learn something. So as way of a quick introduction, I'm Tom Morton. We've been traveling in RVs for over 10 years, utilizing these pickup trucks and all the different types of diesel engines to pull and move them. I've had the opportunity to use all of these engines as well as even rebuild some of them, so I have a really good understanding of the internals and physically have seen what the differences in these engines are. I'm also an engineer, total nerd, and love to dive into details. Now before we really get into it, I want to reiterate the high-level difference between a diesel and a gasoline engine. Honestly, they're more similar than they are different. They're all internal combustion engines. The base technology is over 100 years old, and we're still using the same principles. These are four-stroke engines with pistons that go up and down in a four-stroke configuration. But the big difference, of course, is the fuel. Gasoline and diesel are very different fuels and have very different combusting properties. Gasoline requires a spark or some way to actually get it to ignite or explode in the cylinder, whereas diesel doesn't. Diesel just needs high compression, which spontaneously ignites the fuel. This means that diesel engines inherently want to run. As long as they have fuel, they go. In fact, the only way to control a diesel engine is by how much fuel you give it. More fuel, the faster the engine goes. Take fuel away or cut it off, the engine will stop. In a gasoline engine, you have to control fuel, you have to control air, and you have to control spark. So there's more complexity in a gasoline engine, and that's part of where some of the reliability in diesels of the past has come in. That fuel and compression difference also impacts how the engine performs, however, and diesel engines generally can produce more torque or twist that is inherently better for towing. This frequently comes at the expense of horsepower, however. So a diesel engine is sometimes not as powerful as a similarly sized gasoline engine, but it has more capability to twist without revving so high. This in general is better for a heavy load application and why we see them in the big trucks. Cummins is in the Dodge and Ram series trucks, Duramax in the GM series, and Powerstroke is exclusively in the Ford trucks. Before we get into the engines themselves, let's talk about who makes these engines and why that matters as well. The Cummins engine is pretty self-explanatory. It's made by Cummins, not Dodge, not Ram. It is a totally separate entity. They buy the engine and they integrate it into the trucks. This has some pros and cons. Cummins is an expert at making diesel engines, but integrating it into the truck has some drawbacks. Cummins connectors and Cummins communications are proprietary, so it's actually kind of difficult to work on these engines sometimes when you're dealing with electrical issues. The wiring harnesses between the truck and the engine are not clearly laid out, and sometimes it's a bit difficult to chase down wiring issues or get actual communications issues sorted out. Cummins has their own proprietary in-site communications protocol that you have to use if you're actually going to work on the engine, and it's really a separate entity from the truck. From the end user perspective, it really doesn't matter. The engines perform flawlessly in these trucks, but from a repair and serviceability standpoint, this can be a little bit more challenging. Now, once again, the Duramax engine is not a direct GM product, but a partnership between GM and Isuzu. Isuzu brought the diesel experience and GM backed it. They actually are the primary owner in the separate company D-Max Limited that makes the engines pretty much exclusively for their trucks. Now, Duramax is actually a branded product and includes a bunch of different engines, but we're going to be talking about the largest one, their 6.6 liter that is currently installed in their largest pickup truck. These engines are used in a number of different vehicles, but for the most part, they're designed specifically for their trucks, so integration is better than with the Cummins engine and a little bit easier to actually trace problems and repair, particularly on the communication side. Now that brings us to the Powerstroke, the only one of the manufacturers that actually fully designed their diesel engine in-house exclusively for their pickup truck. The Powerstroke engine is by far the most well integrated with the truck systems, both from a repair, serviceability, and maintenance standpoint. Due to the compact nature of these trucks, the Powerstroke engine also was most designed to be shoved into the engine bay of these trucks and is probably the most compact of all of the engines. This is both a pro and a con, but from an engineer packaging standpoint, the Powerstroke wins in this area. I just wanted to mention this as we've had a number of Cummins trucks that when I've actually done the engine rebuilds, I've run into some of these issues where chasing wiring down can be very challenging because you don't necessarily have the correct truck to engine communication wiring diagrams. Doesn't mean you can't figure it out, it's just a lot harder. Let's now get into the heart of the engines, the block design. The block is the primary chunk of metal that actually houses all of the pistons and the primary componentry of the engine. Starting with the Cummins, the block is a straight six, meaning that all the cylinders are lined up in a straight line and there's 6 of them. The Cummins block has not changed much in 30 years. It's a very straightforward design, and the engine design is actually used in many applications besides just the truck. You can find almost the exact same block in everything from trucks to buses to tractors to off-road generators and all sorts of other applications. It's a pretty robust tried and true block, and the straight six design is arguably one of the best designs in engines for balance. The way the pistons go up and down are counterbalanced against each other tends to make the engines extremely smooth, and it tends to be a very reliable design. In fact, most semi-trucks and big over-the-road trucks still use a straight six design. Yes, those giant engines running semi-trucks are only 6 big cylinders. A big advantage the Cummins block has with that straight six design is that the pistons have a very long stroke. The pistons are what's called over square in the Cummins. It means their diameter, how big around they are, is smaller than how far down the piston travels in its stroke. This long stroke allows for much higher torque applications at lower RPMs, generally what you want for hauling. Again, one of the primary reasons the 6-cylinder inline is chosen for over-the-road trucks. The drawback to this design is that it makes the engine very, very long, and it barely fits in the engine bay of this truck. It also makes the engine a lot heavier. The Cummins is the heaviest of the big three and definitely the least compact. Overall, the block design is the most simple of all the engines. Moving on to the Duramax with a radically different engine block in a V8 configuration. This means we have 2 more cylinders in a V configuration, allowing the engine to be much shorter and more compact to fit in the engine bay. A very interesting thing about the Duramax block is that the pistons are what we call undersquare, or it means the piston is bigger around than the distance it travels down. It's more of a flattened rectangle from the side instead of an elongated rectangle. There's no inherent problem with this, it just means that the stroke is so much shorter. And this inherently can produce an engine that provides much more horsepower, but a lot less torque. Granted, there's 2 more pistons in this engine, so it generally can still get that torque, but it needs to be at a higher RPM. This V8 diesel configuration is very similar to other V8 engine configurations out there, with the air coming in from the center of the V and then the exhaust to the outside. The Duramax block has changed quite a bit throughout the production run, with changes through different engine models, unlike the Cummins, which has pretty much stayed the same. Because of this, you're going to find more differences model year to model year in the Duramax than the Cummins. And that finally brings us to the Powerstroke, which once again is a V8 diesel configuration. The Powerstroke sits somewhere in the middle with a very close cylinder bore to cylinder stroke ratio being almost square. Once again, in the V8 configuration, it's more compact and lighter weight than the Cummins. Both the Duramax and the Powerstroke come in a couple 100 pounds lighter than the diesel engine in these trucks. Now let's move on from the block to the head of the engine, the other half of the engine. In the block, we create that hole that the piston sits in and all the componentry that holds the pistons and the crankshafts, but the top of the engine, or the head that clamps down to that to create that enclosed space, has a lot going on and really is the other half of the engine. Now, in the head is the valving for the air and the exhaust in these engines, and honestly, it's all pretty similar between all of these engines. All of these engines have 4 valves in the top, 2 for the exhaust and 2 for the intake. On the Cummins engine, the air enters one side and the exhaust out the other. It's pretty straightforward. In the Duramax, the air enters the center of the V and the exhaust goes out the outside. This is the most common configuration for a V8. However, the Powerstroke has a very unique reverse flow, as they call it, configuration. This means the air enters the outside of the V, it goes through the head into the pistons and out the center, or what they call a hot valley for that engine. The benefit of this is that all the exhaust is right there in the center and is a very short run to the turbocharger that sits in the center of that engine. We'll talk more about the turbochargers a little bit later. Now, a major difference between these engines was how the valves were actually lifted for a long time. Both the Powerstroke and the Duramax engines have what we call hydraulic lifters, which means there's engine oil pushing up to open the valves for the exhaust and the intake air. This hydraulic lifter design can create a smoother, quieter engine that doesn't require valve lash adjustments, which is pretty nice. The Cummins engine alternatively utilized a very old design with a physical lifter or tappet inside the engine riding on the camshaft. This is a very reliable design, but inherently requires more maintenance getting inside the engine to adjust something called the valve lash inside the head of the engine. Recently, however, Cummins has switched to hydraulic lifters as well, for better or worse. One of the areas all these engines share a lot of similarity is in the fuel delivery. All of these engines are what's called common rail engines, meaning they use a single, very, very high pressure fuel rail, and we're talking 30,000 plus PSI. Then that high pressure fuel goes through tubes to the injectors that sit in the heads of the engine. These injectors are controlled by the computer to actually spray fuel into the cylinders of the engine at specific times to get it to combust once it's compressed. All of these engines utilize that same design with slight variations. The Cummins uses what's called a solenoid injector, whereas the Duramax and Powerstroke utilize a piezoelectric injector design. They have their pros and cons, but generally they perform the same task. They also share almost the exact same fuel pump. The high pressure fuel pump in all these engines goes back and forth between the CP3 and CP4 design. If you want to dive into details on that, that has been a significant reliability issue / concern for a lot of people over the years. The CP3 and CP4 pumps have significantly different designs in them, but they basically do the same thing: provide a very, very high pressure fuel to that common fuel rail that then the engine can use as needed. Optimally, you're trying to keep the pressure up while the engine consumes fuel, and that is a very challenging thing to do. You need extremely tight tolerances and very, very clean fuel to pressurize it to 30,000 psi. Generally, the CP3 has been considered to be the most reliable of the pumps on the market, and many CP4 owners will switch back to the CP3. Now, the Duramax engine actually has used a slightly different pump, an HP4 from Denso, for a number of years, but they too have used the CP3 and CP4 pumps in the past. Regardless, the conceptual design is almost the same. High pressure fuel into a high pressure rail, tubes into the injectors squirt fuel into the engine. But it's a little more complicated than that, in that the way the fuel is squirted into the engine has so much to do with the characteristics of how the engine runs. This extremely high pressure forces the fuel through these absolutely tiny holes in the injector to get it to turn into an extremely fine mist in a very specific pattern inside the engine. This all happens within microsecond timing as the piston is moving inside these engines, and has a lot to do with the engine's performance. Even the tiniest variation in the performance of the injectors can actually cause a significant impact in how the engine runs. Fuel has to be absolutely clean to go through these tiny, tiny holes, and all of these engines have advanced fuel filtering to filter out impurities before it even gets to these injectors. However, due to the nature of diesel fuel, which creates a lot of carbon buildup, and the reason you've seen a lot of older diesels smoke a lot, these injectors can get gunked up. And this is a great time to share about the new Power Service Products Injector Flush. If you haven't heard of Power Service Products, they've been around a long time and make diesel additives to help clean up diesel systems in trucks. They're one of the most trusted brands in diesel additives, and many people run them regularly through their engines. In fact, Cummins certifies a number of their products to be used in their engines, and when used directed, they shouldn't cause any issues with an engine whatsoever. In fact, cleaning up your injectors is one of the best ways to improve the performance of a used diesel engine. What's neat about this new injector flush additive is that it's designed to clean up the injectors, remove deposits, and coking on the injectors in just one tank's worth of fuel. Many other additives require you to use it every single tank, but this is supposed to clean up the injectors aggressively in one use. Now, I can actually say I tested this out on our old backhoe that had really bad injectors, and it made a big difference to the performance. So much so, the engine wouldn't start before, and it started after using the product. I made a short all about it if you're curious. Cleaning up the injectors also can reduce emissions. It reduces soot, black smoke, and can really help the emission systems of the truck. We'll talk about the emission systems a little bit later, but the DPF, which is designed to capture soot, doesn't have to work as hard if the injectors are clean. The product is designed to clean up the injectors as well as the emission system for longer lasting, fewer regens, better fuel economy, and overall a more reliable truck. We've trusted Power Service products for years, have used a number of their additives at different times, and now this new product, I believe, is a great choice to add to your diesel arsenal. So now that we understand that the fuel systems are pretty much the same in all these trucks, and one of the reasons that an additive can help all of them, let's move on to what happens after the engine burns the fuel and goes into the exhaust side. You might just think that the exhaust goes down a tube and out the back of the truck, but that is not the case with these modern engines. First of all, the exhaust goes through the turbocharger. Due to the nature of diesel engines really need forced air into them to get the best performance, and that requires some sort of a compressor. Have you ever wondered why some diesel engines sound like they're running a vacuum attached to them? It's because they basically are. The exhaust goes through the turbocharger, spins a wheel extremely fast on the exhaust side, and that crosses over to the intake side, compressing air and shoving it into the engine. This is called boost. All these modern diesel engines, the Cummins, Duramax, and Powerstroke, all operate under boost or pressurized air entering the engine. They are not what's called naturally aspirated, meaning that they suck air in themselves. Now, once again, the turbochargers are actually more similar than different on all of these engines. They're all what's called VGT or variable geometry turbos. Inside these turbos is a mechanism that moves back and forth and controls how much exhaust goes across the fins of the turbo to increase or decrease its effectiveness. Now, running a turbo actually uses energy from the engine. You got to think of an engine like a giant air pump, because that's actually all it is. An internal combustion engine is nothing more than an air pump that operates by putting fuel into it. If you look at an air pump's design, it's pretty much exactly the same. All we're doing is trying to take a little bit of this excess power off of this air pump to turn our wheels. We can take energy off it in a number of different ways, and one of them is actually the exhaust, putting pressure back on the exhaust system and taking energy out of it. We get that energy back, however, by putting more oxygen into the engine to get a bigger boom. That is why it's worth it to take energy off the exhaust to get more energy out. Now, the turbo has changed significantly on all the different engines, not so much the Cummins, it's pretty much remained the same. Powerstroke particularly tried a couple different turbo geometry designs that really hadn't worked out well, so we're all back to using a pretty basic variable geometry turbo design. The biggest difference between the turbo configurations is that the Powerstroke's turbo sits right in the middle of the engine, actually so does the Duramax, but this one is so close to those exhaust manifolds that it has some of the shortest turbo spool. Spool is how long it takes for the turbo to get up to operating pressure and start producing that additional power. After the turbo, the exhaust goes out the tailpipe. Well, not quite. There's a significant complex emission system involved in all of these trucks. All of these trucks have SCR or DEF additive emission system, which actually sprays a fluid into the exhaust to help break down the exhaust further and improve the emissions control. In addition, all of these engines have EGR, what's called exhaust gas recirculation. Due to the physical design of the engines, they all are a little bit different, but they all operate in a very similar manner. All of them have cooled EGRs, which means they're using the cooling system to actually cool the exhaust gas before it goes back into the engine. It might seem counterintuitive, but yes, actually getting the engine to rebreathe some of its exhaust can significantly lower its emissions. In the early years, these emissions were extremely problematic on these engines and caused a lot of failures. In fact, this engine here had a complete meltdown due to a clogged EGR. Sensors and the emission systems themselves have gotten a lot better over the years and generally are a lot less problematic. For a long time, the emission systems actually could cause additional wear on these engines, but in current emission systems, it's a little more nuanced. They've worked out a lot of the bugs, and in general, some of them can actually enhance reliability of the systems. In general, the emission systems aren't really a deal breaker on any of the particular engines. The Cummins probably struggled the most with them originally, but they seem to have figured out most of the problems. And they're generally all pretty much the same. Now back to the air system. After the turbocharger compresses that air, it gets really hot and it needs to go back into the engine. So generally we want to cool that air down. To do that, we use something called an intercooler. We actually cool the air after the turbocharger going back into the engine. And this is done differently based on the engines. In the Cummins, the turbo is on the passenger side of the engine and the air has to make it over to the driver's side. This actually works out great for cooling the air because we just put a giant radiator in the front of the engine called the intercooler that the air goes into, the temperature drops, and then it goes into the engine on the other side. Very simple and effective design. The Duramax has used a number of different designs for cooling the air over the years, but generally it uses a very similar intercooler design. The Powerstroke, however, uses a very different concept. It uses what's called an air-to-water heat exchanger. This again allows for compactness of the engine, but the air actually goes through basically another radiator that uses the cooling system or another radiator up front to cool the air utilizing water or the radiated cooling system. And this is where we could start diving into the cooling systems of the engines. Now the Cummins and Duramax use a pretty straightforward cooling system design. They run coolant through the engine, up through a big radiator up front, and then back through the water pump. Pretty straightforward. Powerstroke, however, has a very complicated cooling system design in contrast. The Powerstroke engine utilizes a multi-temperature, multi-radiator design to offer different cooling temperatures to different components. The engine is generally going to operate at a much warmer temperature than, say, what you're trying to cool the air for the intake with that intercooler, air-to-water intercooler we talked about before. That requires a completely separate cooling system and a quite complex cooling circuitry in the truck. The Powerstroke has two different radiators and basically two different cooling systems altogether. Over the years, they've used the different cooling systems for different components and switched back and forth a couple times. Now, while this cooling system is more complicated and some would say over-engineered, it does allow for that nuanced control of temperatures in the engine, which can be really beneficial. So now that we've got a high-level overview of some of the major differences between these engines, I want to talk briefly about generally their power and torque and comparisons. The displacement of these engines is almost the same in all of them, just in very different configurations. And generally that pretty much means their power outputs can be pretty much the same. There's an old saying that there's no replacement for displacement does still hold true. If we have the same displacement, we should be able to get about the same amount of power. And they have crammed a lot of power out of this amount of displacement in recent years. The blocks and displacement has stayed about the same over the last 20 years, but the power has pretty much doubled, which is wild. The big three have gotten in power wars between all these trucks, and a lot of that comes down to marketing and sales. Is it actually necessary to have that much power in a pickup truck? I would say not. But the general consumer, you and me, want our pickup trucks to feel, say, more like a snappy car. So they've pretty much tuned these engines and modified them to perform more like that for the general user. Diesels inherently are going to be slower though. They have that low end torque, they can operate at lower RPMs, but they generally aren't as quick. Could the trucks 20 years ago still do the same thing? Well, mostly. They did have lower towing and actual usability characteristics, but you still could do it, just a lot slower. You gear this engine down, you gear any engine down, in fact, and you're still going to be able to get that torque to the wheels. A gasoline engine can tow just as well as this truck. It would just have to run higher RPMs with lower gearing and go slower. You ever notice semi trucks going up hills so incredibly slow? It doesn't mean they can't do it. They do it just fine. Their power to weight ratio is just a lot lower than your car or your pickup. I do want to note, however, that this isn't necessarily a good thing. The more power you put into these engines, the more wear you put into them as well. In fact, in all the brands, the cabin chassis trucks, which you'll notice this is a 5500 with a flatbed, actually have detuned engines. They make a lot less power than the pickup truck version of the same model. The 1-ton or 3/4-ton trucks have more power in them with the exact same engine. Why? This truck is going to be used hard all the time, and if we put that much power in it, we're going to wear it out so much faster. Yeah, this truck goes slower, but generally it's heavy use, it's going to be better off with less power. Our motorhome has a 14-liter Detroit diesel engine in it, and it can pull hills like nobody's business, but boy is it slow. It only makes about 500 horsepower, not a whole lot more than this engine, even though it is so much bigger. It also has a much longer stroke, however, providing even greater low-end torque. We're talking a lot greater low-end torque. And that's kind of the biggest benefit to the diesels, is that low-end torque. And that's partially where the Cummins will win out, having that longer stroke. Not significantly so, but it's still going to be able to provide that torque at a lower RPM. So with all this talk of power, I want to turn around and talk a little bit about reliability. You've probably heard diesel engines are more reliable than their gasoline counterparts. Is this still true? I would say not as much as it used to be. With the advanced tuning and high powers that we're pushing out of these engines, we are going to see wear a lot sooner. These engines are also so much more complicated with all this stuff strapped onto them than they ever had before. So the likelihood of getting to 1,000,000 miles without a major problem is so much lower. Now, the inherent design of a diesel, designed for higher loads with larger cooling systems, is usually going to improve the wear a little bit more over a gasoline engine, as well as the biggest difference, their operating speed. These diesel engines can operate at much lower engine speeds, and generally with every rotation, there's a little bit of wear. So if you're operating at half the speed, you in general have half the wear. Okay, it's not quite like that, but it does play a big factor in the engine's reliability. Also, these engines have as tight a tolerances or even tighter than modern gasoline engines, which can be a drawback. As tolerances get off when the engine wears, things don't operate as well, and more things can go wrong. You really have to know what you're doing if you're going to do some deeper engine modifications because of these tight clearances and tolerances in these engines. These engines are also what's called an interference engine, meaning that the pistons will physically hit the valves if things don't move out of the way in the correct sequence. And if the timing or the clearances are off just a little bit, you can have a catastrophic problem. In the past, diesel engines were a lot more sloppy, if you will. They had a lot of wiggle room for error, and that tended to make them more reliable. But they also weren't as fuel efficient, were super dirty, super noisy, and generally a less enjoyable engine to use. Now that we've turned them into these amazing beasts of an engine, we are starting to see probably less reliability than we had in our previous diesels. So all that being said, is one engine better than the others? Would you choose a Cummins Duramax or Powerstroke? Well, I'd say they can all do it. I've used all of them, and they all have more than enough power for general pickup truck needs these days. From a usability perspective, I'd probably be looking at other aspects of the truck before making a decision based on the engine. From a very long-term reliability standpoint, the Cummins probably still stands out just a little bit because it is a simpler block and simpler engine design overall. From an engineering perspective, I would give it to the Powerstroke as being probably the most impressively engineered engine. The Powerstroke's packaging, its sensors, and the general control they have over the Powerstroke is far superior than the Duramax or the Cummins. That, in general, is pretty cool to an engineer like me. However, from an end user perspective, none of these things really make or break the truck. The manufacturers are also modifying and tweaking every single year, so problems that they may have resolved in the past, they may have created new ones in the future that I can't necessarily say what they're going to be. I do want to leave you with a little food for thought, though, that all of this is really the epitome of the internal combustion engine. I think we are kind of at the best of the best, pretty much as good as we can get with these engines. I don't expect to see significant increases in power, fuel efficiency, etc., without making a significant powertrain design change. The technology in these engines is generally very old, and there's been a lot of trial and error, and we have a pretty good product in all of the trucks. If we want to really push the envelope, however, it's probably time to start looking at a different engine geometry. Cummins actually recently released a opposed piston design where the pistons come at each other like this. Again, not new technology, but a neat way to eliminate some complexities of having a head in an engine. Maybe totally rethinking the engine like that, or thinking of hybridizing these trucks. Yeah, adding some electric motors to add that additional torque, maybe make the engine a little smaller. Having been through a number of engine rebuilds myself, I see a lot of areas for incremental improvement, but nothing earth-shattering within any individual engine. None of that's going to stop us from using our engines, however. We have so many more adventures to have. We just finished the rebuild of this particular truck, and we're about to hit the road, and we're going to share some of our adventures. So we hope that you join along. As always, thanks for watching us here on Morton's on the Move. Thanks for joining me through this really long rant if you've made it this far. I've actually had some requests for this rant, so I wanted to put it together for you. Hope you've learned something today. Safe travels out there, and we'll see y'all down the road.